Hey, g'day, it's Prezzo. Welcome back to the shop today. Now this is part 2 of restoring a Taipan Tyro 1.9cc diesel model aircraft engine. Now this was an engine that belonged to me as a youngster and I flew it in control line aircraft and had a ton of fun with it. I found it recently and I decided I should restore it, make it look nice and see if I can run it, because it's over 50 years old and I figured it would make a nice little addition to a collection of engines that I built over the years. Now in part 1 I made some new parts for the engine and I did some of the finishing processes. We also looked at the history of the Taipan Tyro engine and the manufacturer Gordon Burford. Now he operated out of South Australia and the Taipan Tyro was regarded as a beginner's engine, and that's the reason why it was the first engine that I ever bought. Now today we're going to have a look at the remaining finishing processes on the parts, and then we're going to reassemble it and see if we can run it. Let's have a closer look at this part. Right, this is a fairly critical part of these little diesel engines. This is actually a 3-part assembly. This bottom section here is the cylinder liner, and this is a cooling fin cap. I really don't know what the correct name for this part is, but it's an aluminium alloy turning, and this needs to be cleaned up and we're going to anodize this part. Now it's got a lot of oxide on it and it's also got some damage. So at some point this engine is being dropped on something hard and there's a flat section just here, and I want to be able to restore the geometry of this part without actually cutting anything off it. So I'm going to do that in the lathe. We're going to attempt to do it and then we'll get this polished up ready for anodizing. Now this part here is actually 2 parts. There's a thing called a contrapiston in the end of the liner. Now this is a disc of iron or steel that's a fairly tight fit in there. So it's not really an interference fit, but it's a very close fit. It won't fall out, but you could press it out from the inside if you needed to. Now somebody had asked in the previous episode if I'd removed the contrapiston, and the answer is no. I don't see any need to remove it. It does move and there's no corrosion or dirt or anything there now. It's just been cleaned. So I'm going to leave it in there. And in operation, when the engine is running, you can adjust the compression by jacking a screw through the top of the cylinder cap to engage on the top of the contrapiston. You can drive the contrapiston down to increase the compression of the engine, and if you slacken the screw off, the compression will actually push that little contrapiston back out again. So it's just a convenient way of getting variable compression ratio on the engine, and it's just a second way you can tune the performance of the engine. The other way, of course, is by increasing or decreasing the fuel flow through the engine. This part here is the compression screw from the Taipan Tyro. This screws down through the cylinder cooling jacket and engages on the contrapiston. On the original Tyro, these 2 little wings here were straight. At some point I decided to bend them up at that bit of an angle there because I thought it looked cool. And I'm going to leave it as it is because that's how I used to run the engine. If I try and straighten those, I might break those pieces of wire or bar. So what I'm going to do now is try and remove as much of the rust as I can, get this back to bare metal, and we're going to zinc plate this and then put it in a black passivate dip, and that will replicate the look of a chemically blackened piece of steel, but it's going to be more corrosion resistant. This steel was pretty badly corroded and pitted on top. I think we have to accept we're not going to get this looking pristine. So the best we're going to do here is to polish this with emery. I ran the file over it just to remove the worst of the burrs, and then when we get it zinc plated, the zinc will help to disguise some of the pitting, but it's still going to be there. It needs a bit more work, but we're getting close. I'll keep at it and we'll come back and have a look at it when we're done. Just looking at these marks on this piece of material, I can almost guarantee that as a kid I would have just grabbed this with a pair of pliers and just bent it. And the marks that I'm seeing are sort of like the serrations from the jaws of the pliers. Well, good on you, Mark, you did a good job. There's the rain again. Got that about as good as I'm going to get it now. I did machine the end of the screw and just re-chamfered it, but the rest of it's really hard to get at, so I'm just going to call it quits there. What I'll do now is dip this in some hydrochloric acid to strip the last of the oxide off it, and then we'll go straight into the zinc plating bath. So steel reacts quite strongly in hydrochloric acid, or muriatic acid if you like to call it that, but this will just clean and etch the surface slightly, give it a quick rinse, and it's good to go in the zinc bath. Alright, it's about as clean as we'll get that. Okay, I got the part in the zinc plating bath. If you go back and check out my previous video on finishing the Titan engine, you'll see more detail about this process. I'm just about to switch on the power supply, so 5 volts and about 250 milliamps. We should start to see the zinc being deposited almost straight away. You'll notice I've got the heater on in the back of the bath here. You want to have this zinc plating bath up to about 25 to 30 degrees Celsius. And already you can see that that sort of dull grey appearance on the part. I never get these parts coming out like chrome plate, but that's not the look that I'm after. Once this goes in the black passivate, it'll come out with that sort of a dull eggshell finish, which is what I want. So we'll let this go for about, I don't know, 3 or 4 minutes. That should be enough. That's what it looks like when it's done, but this will need cleaning with some steel wool, and that'll bring the shine back, and then we're going to put it in the passivate. So this is what I'm using for the passivate. It's just called black zinc. You can buy this from Jane Kits, and you use it neat straight out of the container, dip the part straight in. So let's just see how this responds. So the reaction is pretty quick. I'll leave that a bit longer. I wanted to go the same sort of finish that you'd see on a chemically blackened steel part, and that's getting pretty close now. Okay, well there it is. We'll leave that to dry now and see how it looks later. This is my CO2 laser setup that I use in my workshop. This is in my wood workshop, which is not ideal because these are optical instruments and wood dust is really the enemy of any optical assemblies. But I keep it covered up when I'm not using it. I've just bought a cheap barbecue cover to put over this. The stand and the laptop all fold up against the side of the machine there, and when the lid's down and covered up, it sort of takes up a space that's around about, what's that, like a metre by about 800 millimetres, and it's on casters so I can wheel it around if I need to. And now I've got this machine to the point where I can do a lot more with it than you might imagine, and I'm going to try and show you an example of that shortly. This is the shape of the gasket we're going to cut out today. Now I've done this in CorelDRAW because I own it, but if you don't own CorelDRAW, it's very expensive. You can use Inkscape and it's free and it does the same job. So once I've created that geometry there, I save that as a DXF file, and then we can open that in Lightburn. Here's the same geometry in Lightburn, and I'm setting my parameters for cutting paper with a speed of 20 millimeters per second, and I'm using 38% power. Paper we're using is a parchment, and it's very thin and quite tough and strong, and I'll probably cut 2 or 3 of these in one go so that I've got a couple of spares. Right, just put that parchment paper in the machine. I've turned the air assist off because we don't need it for cutting paper, it just makes a lot of noise. And there's also a chance that I'll blow some of the small pieces out before the outline is finished cutting. So I'm going to run this now just to check the frame, the outline of where it's going to cut the parts. And that's going to give us 4 gaskets. So let's go ahead and cut those. So you can see how quick and simple that is, and if you ever needed more of these gaskets you can just keep them on file and cut as many out as you want. This is a good example of how you can use the CO2 laser engraver in your workshop. Now this is 3mm thick aluminium sheet, and I've got a piece sitting in the machine already that's been painted with some black spray paint. Now this is for the front panel on a CNC controller for my little C milling machine. Some time ago the old CNC controller died and I want to build a new one. And in this piece of stock here I've got to be able to drill and cut out holes for switches and connectors and LEDs and all sorts of things. And doing it in the CO2 laser means I can get absolute precision about where those holes go. And I can actually mock this up and have a look at it and check to make sure everything's going to fit. And if I don't like it, I can just sort of clean the paint off, put some new paint on and do it again. If I had it's like a CNC router, yes, you could do it very quickly and easily that way, but it's a bit of a one-shot deal. If you screw it up, you've got to get some new stock and start again. This at least gives me some control over where things go. I just stopped that because I don't really need to cut the outline of the whole panel. Let's have a close-up look. This is sort of like the guts of the CNC controller. It's been sitting on the bench here for a long time while I was finishing off the Titan engine. But this is the part that we just did, and this is going to be the front panel of the controller. And what it means is that I can mock this up and hold it in place and make sure I've got clearance in behind there for all of the switches and connectors and so on. So I've got to fit like a main switch there. I've got some of these sort of aviation connectors. That one there is for the probe. I've got an e-stop switch that'll fit up there. And it's just a way of, mocking it up and make sure I got things right. And what I'll do now, if I'm happy with it, I'll center punch the position for each of the drill holes. Now these have got flats on the side, but I'll do that later. I'll actually make a separate front panel out of some laser engraving plastic, and it will have the flats so that the fittings don't rotate when you tighten up the nuts in the back there. So that's just another way that you can use the CO2 laser in the workshop. Also cut out these little parts here. These are for a clock that I'm working on. And yeah, I could cut this up with a saw and file and polish the edges and so on. But the laser is just so much quicker and more accurate for doing this sort of work. So there you go. If you don't own a CO2 laser, you need to get one. So the next job I have to do is to prepare this part for anodizing, and that means cleaning all the oxide off this material and getting rid of any scratches and dents and marks in it. And this is a bit beaten up. I think I avoided the ground contact warranty with this aircraft engine when I was flying it as a youngster. So it looks like it's been driven into the dirt quite a few times just here. And there's that large dent on that edge there. So what I've got here is a mandrel that I've made up. This is threaded the same as the cylinder liner. It's relieved in the end there so that I can fit the inside of the cap up hard against that surface there. So that can just screw on, and this will allow me to work on this and keep it concentric. So the plan here is to try to repair this little dent. So let me zoom in a bit closer and I'll show you. Hopefully you can see that dent quite clearly. It's reasonably deep, and if I were to machine this surface to get rid of that dent, I'd have to go a fair way to get to the bottom of it. So what I'm hoping to do is to form that metal back to where it came from. I'll show you how I'm going to do that. So what I've got here is a ball bearing on the end of a piece of hex bar stock gripped in the quick change tool post, and I've aligned the circumference of that bearing with the angle of the top of the cylinder cap. So with the lathe running at low speed, I can apply some force to that surface, and hopefully whatever metal has been disrupted upwards can be pushed back again. Then I'll do the same thing on the outer surface, the outer diameter of the cap. Alright, didn't feel like much was happening there, but we'll try this outer surface now. The dent's still there though. I'm just going to keep working at this and see if I can get a little bit more of that metal to move. I'm not sure if you can see it. Wait till I zoom in. That time I can actually hear the bearing bumping against this protrusion here. So that's where the high spot is. I'm just going to give it a bit more and see if we can get a bit closer. Okay, that's still there, but it's about half the size that it was, and I can actually see a high spot, like a bright patch, where that metal is being pushed. So I'll just do a little bit more. You can see a bright patch there. That was an obvious dent. It's been pushed back. There's the mark there, and I reckon we can get this out now with just a bit of careful filing and sanding. So yeah, that's worked. Not completely, but we got close. I'm just going to start off with a long angle lathe file. These are designed specifically for filing round parts in the lathe, and I'm just going to use a bit of WD-40 as a lubricant. There is the remainder of that dent, and it's still there, but I'm going to just very gently round that edge. I think that's going to prevent that from getting scarred and dented in future. So not sure what the original factory spec on that would have been. I can't imagine it was razor sharp. It probably had a slight chamfer on it. Okay, I think I've got that. Now, I had to go back to using the file again, and I'm trying to find it now. Yeah, I think it's gone. Maybe just there, but you'd have to look close to see it. So I'm happy with that. Now I'm going to try and clean in between the fins, and I'm going to use a tip that was sent to me by a viewer. Okay, for this first phase I'm just going to use some 400 grit wet and dry, and that's wrapped around my steel rule, and I'll get in there and try to clean the sides of the fins, and then to get to the bottom I'll use this tip that was sent to me. But let's do these first. That was more about sort of removing any nicks or damage on the edges rather than trying to really polish the inside of those fins. I'll use like a nitric acid dip before I do the anodizing on this, and that will chemically brighten the part. It won't polish it, but it will remove the oxide. Okay, to do the rest, I'm going to use this stuff. This is Auto Sol, and I'm just going to smear a bit on the outside of the fins and down into the gaps. Shouldn't need a lot. Alright, now we're going to use some dental floss. So I've got some of this dental floss tape, and we're just going to put that into the grooves and wrap it around and try and polish inside each one. Okay, that worked really well. It's going to take some cleaning to get all of that polish out of those deep grooves. I can do that in the ultrasonic cleaner. And this bottom surface here is going to need a little bit more work. But overall, that's looking way better than what it was. I did do a little bit more work on these parts yesterday, so this bottom surface here is now nicely polished. It was hard to get out originally. That top surface there had a little bit of oxide still on it. That's gone. So we're going to do the cylinder cap and the spinner. So let's anodize. Okay, anodizing is done. I'm super happy with the way that part turned out. That was made from 6011 aluminium alloy, and the colour is really intense and the shine is great. This part here, I'm not sure what grade of material that would be because that's a factory part. It's not quite as shiny, and the colours, or a little bit of the colour leached out actually when I sealed it, but still okay. So these parts are going to go back together again now. I'll do that in time lapse and then we're going to run it. Okay, let's run it. Here's set up, so I just got this bolted down to a piece of 18mm plywood. I had to relieve it underneath here because I didn't have bolts long enough. Clamp to the bench. We've got our little tank that Colin gave me, held down with a strap clamp here. We're just going to fill up with diesel fuel. That tank holds a lot more than it looks like it does. There we go, that's full. Okay, so I've positioned the prop so that it starts to come up on compression at around about 2 or 3 o'clock. So that way you can get a full swing across the top and get your fingers out of the way before it fires, or that's the theory. Now I've opened the needle valve about 2 turns and I've backed the compression lever all the way off. So yeah, that should be fairly loose. I'm going to prime the fuel tubing. There's fuel coming through there now. Okay, let's see if we can get a few pops. That's encouraging. Well, there's a lot more vibration with that than I imagined there would be. The clamp came loose, the whole thing's bouncing on the edge of the bench. I think I need to get this held down more securely. Let me see what I can figure out, but yeah, it runs. And I'm sure that I can tune that to run better than what it was just now. Alright, here's Mark II. So I've got a really heavy piece of wood underneath that now. I've screwed the plywood down on top and I've got a bigger clamp onto the edge of the bench. So let's see how we go now. Well, part of the problem was the fuel tank was empty. I can't believe I did that, and I don't know where all that fuel went. But that's running, and it's as oily and filthy and smelly as I remember it used to be when I was a kid. There's a bit of leakage coming out the top of this cap where the compression screw goes in there. That could be the contrapiston leaking slightly. Doesn't seem to affect its performance though. But I'll make a note of where that needle valve is, so that was a good running position there. And I think when you start it, you're meant to back that compression screw off, maybe a turn, just to make it a bit easier to start. Alrighty, so it does run. What I'm going to do now is we're going to check the RPM of the engine with this prop and then check it against the data that I got from the book that was loaned to me. So we'll see how closely we're matching the specs of the original engine. This is the page that I took from the book, and this is for the Taipan Tyro, and it says with an 8x4 prop, which is what that is, we should be able to get 11,900 RPM. So we're going to tune it, see if we get close to that. I've put some reflective tape on one blade, and I've got my El Cheapo tachometer here. We'll see if that'll work. Let's hope that doesn't throw the prop out of balance. Alright, so I read 10,900. It was jumping over the place a bit, and you had to get the laser right on that tape, which is a bit hard to see when it's spinning. But 10,900, and it said we were supposed to get 11,900. Maybe I could have tuned that a bit better, but you know what? I'm happy with that. So I'm going to clean this up, and I'm going to put on a little display stand. I'll show you that, and then that's the end of today's video. So yeah, after 50 years it still runs, and yeah, like I say, it's as greasy and dirty and smelly as ever, and it's just sprayed my car with diesel fuel. Anyway, let me get it cleaned up and we'll have a closer look. Okay, ready for this? Boom, there it is. Now this is going upstairs. I've got a cabinet with a lot of other models and engines that I built over the years. It's not going to fly. Some people have asked me if I'm interested in putting it in a model aircraft, and the answer is no. I'm too old for that sort of thing. However, I did find the original drawings of the very first model that this flew in, and it was called the Taipan Trainer, and it was made by Aeroflight. It was a kit plane, and as I recall, it was a difficult plane to fly, certainly not what you should learn on. Ended up being way too heavy, and I think I crashed it on its maiden flight. And I broke off the hardwood engine mounts, and once they get soaked with oil, it's very difficult to repair. But there you go, that's the Taipan Trainer. Now this little display stand was made mostly on the laser cutter engraver that I showed you earlier. So these two parts are made of 5mm thick clear acrylic, and the nameplates here are made of a 2-ply laser engraving plastic. Now you can buy this in lots and lots of different colour combinations and thicknesses. If you're going to do this, though, you need to make sure you get the correct one. There is a rotary engraving type plastic which doesn't cut very cleanly on a laser cutter engraver. It tends to burn and melt, so you need to make sure you're getting the laserable plastic type. And these are just an easy way to make professional looking nameplates and plaques and maker plaques for projects that you build. So like I said earlier, a laser cutter engraver is a tool. It's not just for making pretty things, you know, it can be used for marking out, cutting, mocking up, doing rapid prototypes and so on. So if you want one, you can just tell your partner that I said you need to buy one, okay? They can blame me. Okay, I'm going to finish up this video now. Appreciate all the new subscribers that have got on board, and also the very, very positive comments. It seems like model aircraft and aero modelling in general is a very nostalgic topic amongst a lot of people, and rightly so. I certainly enjoyed it as a child. So I hope you join me for the next video. I'm going to finish up now with a little bonus nature documentary. So it's Prezzo signing out. See you next time. Cheers. A few videos back I showed this scrub turkey that's been hanging around our place for about the last month. It was a regular visitor, was here most days, comes up quite close to us, won't take food from your hand, but it's quite unafraid. And because it was a regular visitor, we called him Tommy. Well, it turns out he's not Tommy at all, because he brought a friend home with him, or her. So it's actually Tammy. So here's Tommy over here. We're pretty sure that Tommy's built a nest, probably in the block next door, and we're pretty sure he's trying to entice the female, Tammy, to come and lay some eggs in the nest. Yep, I reckon that's where they're going. Pretty sure if we explored in all of this bush here, we'd find the nest or the mound. What's up, Raph? I'd leave them alone if I were you.